In this video, I want to introduce to you sine and cosine functions. And basically, sine and cosine functions represent what we call sinusoidal functions. All right, so some examples in the real world of this is going to be a heartbeat, because you think about what that looks like on, a heartbeat monitor, but tidal levels. So, tides, we have high tide, we have low tide, all right, and that fluctuates throughout the day. Sound waves, also the time of sunrise, it kind of staggers a little bit. Okay. So every day it might be a little bit later and then it kind of goes back. Okay. Temperatures, how temperatures fluctuate. We have, in the winter, we have much lower temperatures, but then in the summer, they go back up and then back down and back up, that kind of thing. All right. So these are examples of what we consider a sinusoidal function. Another example of a sinusoidal function is what you would see with a Ferris wheel. And this is kind of what we've talked a little bit about in our class. So I want to kind of show you that and what it looks like, how we kind of transfer this over to a more linear looking graph. All right, so here's my Ferris wheel. Okay, so if you think about your Ferris wheel, what happens? You jump on the Ferris wheel right here and you're at 0. Okay, so I'm kind of starting at 0. Let me see if I can bring this up a little so you can see both. All right, so I'm starting at 0. Well, what happens when you get on the Ferris wheel? Well, it goes up. All right, it goes up. And then what happens? You start going back down, but you keep going down, right? We go down a little bit more. So I'm going to go down a little bit more. But then eventually I go back up and I'm right back to where I started. So, like, I started at ground level and then I'm going to end at ground level. So, this is going to represent kind of more like what you see on your unit circle, but this is more of a linear kind of representation of that unit circle. Okay. So, this is where the sine curve comes from, basically. Okay. How we kind of transfer it from sine to, or sine on the unit circle rather, to sine on more of a coordinate plane. All right, and we could do the same thing with cosine, like if we looked at all of the cosine values instead. All right, but this is just a representation of sine. All right, so here's a picture of what sine looks like on this graph. All right, so something that you need to understand about your sine functions is that sine and cosine both, they're considered to be periodic functions. All right, and periodic just basically means that it's going to be a pattern, all right, or a graph that has a repeating pattern and it's going to continue indefinitely. Okay, so what that means is if I have, a graph and if this is, you know, my sine function, well, then it's just going to keep repeating. So I've got that sine function, it's going to repeat again. All right. And then it's going to repeat again. And then it's going to what? Of course, repeat again. Because think about the Ferris wheel. Well, if I'm on the Ferris wheel, I'm just going to keep going. Yeah, I got back up to ground level, but now I'm going back up, back down, down some more, back up. Oh, it's going to rotate again. So basically, this right here, what you see represents one rotation or one cycle around the Ferris wheel. Okay, if you just want to use that as the example. All right, so they're telling us here that sine functions as well as cosine functions are periodic. It just means that it's a repeating pattern, it's continuously indefinite, so it just never stops. The shortest repeating portion of this pattern, though, is called a cycle. All right, so that cycle is just one rotation, one of those repeating portions. Um, Now, the horizontal length of each cycle is called a period. All right. So you'll notice right here, this represents one cycle or one rotation. And then right here, that represents one period. All right. And then this would be a whole nother period. So it's like a period, a period, a period, and so on. Another term that you'll see on this graph is the amplitude. All right. So an amplitude measures the height from what we call a midline to the top of the graph and the midline to the bottom of the graph. All right. So I'm referencing this midline, and basically this is the midline. All right. Now, a midline in what you see here is on the x-axis, okay? But that's not always going to be the case because sometimes you'll have shifts in your graph, so that may fluctuate. Okay, it may move up, it may move down, depending on what's going on. All right. So the amplitude represents the distance from that midline to the top or that midline to the bottom. All right. Now, because amplitude measures distance, amplitude will always be positive. So you're going to see some formulas here soon, and it's going to talk about, the absolute value, and it's because we're measuring distance. All right. So again, a period is the length of a cycle. So we use period to measure the length of a cycle, and the amplitude measures the distance from the middle, which is the midline, to the top of your graph, and the midline to the bottom of your graph. All right. You want to also notice that sine starts at 0, 0. Okay, so we'll talk about that again here in a little bit. Now, there's also some other characteristics that you'll notice on this sheet. Okay, so it tells us that the domain and the range. The domain is negative to positive infinity. That's because this graph is continuous. It's going to keep going and it's going to keep going. So it's going to go forever left, forever right. So that's why it's negative to positive infinity. The range, however, is going to be -1 to +1 because how low does it go? -1. How high does it go? +1. But keep in mind, those numbers can fluctuate depending on what the amplitude is. So really, it's just the amplitude. So it might be -4 to +4. Okay. Or depending on how it shifts, it could still be -2 to +4. There could be a shift that causes it to look a little different. All right. So amplitude to amplitude. Or wherever that bottom part of the graph is to the top part of the graph. The sine function is an odd function. All right. And that's because it's symmetric about the origin. So in algebra 2, you learned about odd and even symmetry. So for odd symmetry, it has to go through the origin and it has to have 180-degree rotational symmetry. So everything will be flip, flop, opposites. Okay. And this happens here. So it will be an odd function in terms of symmetry. Um, it also has, we've already talked about this, but it's a periodic function with the period length of being 2 pi. We'll get more into the x-intercepts, maximums, and all that as we go. All right. So the amplitude is going to be 1/2 of the distance between the maximum and the minimum. So like here, what's the distance here? Well, there's a distance of 2 from the bottom to the top, but half of that is 1. So that's why the amplitude is 1. Oh, y'all cannot see that. All right. But half of the distance, so 1 this way, half of 2 is 1. All right. So 1/2 the maximum minus the minimum will give you your amplitude. Now, the cosine graph is pretty much the same, except for the starting point is different. So the starting point here starts at 0, 1. Now, it's not always going to be 0, 1. It's just going to depend on what the amplitude is. All right. You're going to also hear me refer to this more as my uterus graph, okay? Because it kind of has that uterus shape. And I know that sounds kind of crazy, but believe me, it will help you remember it. You're going to ask me during a test or whatever, you'll be like, is this the uterus graph or what? Okay. But it just has that shape. So just kind of bear with me. All right. So the domain here, and I'll get more into some of these characteristics, but the domain is negative to positive infinity because it's continuous as well, just like the sine graph. Same thing with the range that we already talked about, but this time the cosine graph is an even function because number one, it doesn't even go through the origin, so it can't be an odd function. But an even function is when everything basically has a fold line of the y-axis. So if everything is symmetric, like if you could fold it in half and it match up perfectly, then that would represent an even symmetry, and that happens here. So that's why it's even. Um, it's also a periodic function. Its period length is also 2 pi. The amplitude we also get by doing 1/2 the maximum minus the min. So none of that is any different. It's really going to be, the basic look of the graph in terms of how it looks in one cycle at least versus one cycle on the sine graph. So one cycle on the sine graph kind of looks like a snake. One cycle on the cosine graph looks more like the uterus graph. All right. They have different starting points. Okay. So your sine graph starts at 0, 0. Your cosine graph starts at 0 amplitude. All right. But you'll notice that on a larger scale, it looks pretty much the same. All All right, so it looks like a wave. So if you look at page 5, I want to talk to you about how to find period and how to find amplitude. All right, so amplitude is going to be the number or the coefficient in front of your sine or cosine graph. All right, so in this case, you have a 2 in the front. In this one, you have a 1/3 in the front. Well, because the 2's in the front, that means you have an amplitude of 2. The 1/3 is in the front, that means you have an amplitude of a third. Okay, now period is going to be a little bit different. All right, so with period, we're looking at 2 pi over the absolute value of b. All right, so b is whatever number or value is in front of the x. So 2 pi divided by whatever that is. Now that number could be a pi, it could be a 2, it could be a 7. I mean, it could be anything. It could be a 2 pi, it could be a 5 pi. All right, but you take 2 pi and you divide it by whatever is in front of that x. All right, so I also want to mention that amplitude, I didn't really say it very well here, but amplitude is absolute value. So make sure amplitude is always positive. So if there was a -2 right here instead of a +2, the amplitude would still just be plain 2, +2, because it's not going to be negative. All right. If there was a negative in front, it would mean that there's a reflection, but we will talk about reflections a little bit later as we go. All right. So back to period. So for this first function, the period would be 2 pi divided by 4. So that's what you see right here, which would reduce to pi over 2. All right, here there's 2 pi in front of the x. So that would be your b. So 2 pi divided by b, which just happened to be 2 pi. Well, 2 pi divided by 2 pi is 1. All right, so some other things real quick to remember is what we have here is our 2 graphs. I want you to remember that this represents a sine graph, and where does it start? 0, 0. That's a real important characteristic. All right. This is a cosine graph, and where does it start? 0 amplitude. All right. Some quick reminders that what you see here represents one cycle, which has a length of 1 period. Okay. 1 period represents the length of one singular cycle. And for both sine and cosine graphs, it's 2 pi. All right. So this represents the length being 2 pi. All right, so this looks like my snake graph. This looks like a uterus graph. Okay, so that's just some quick little tidbits. The points that you see are what we will consider to be critical values. So these 3 points that you see right here are intercepts. All right, and this graph only has 2 intercepts, but the intercepts are where you cross the x-axis. All right, now this x-axis is also referred to as the midline. Okay, keep in mind that this midline will not always be your x-axis. All right. And that's because eventually we're going to talk about shifts and then that will change things. So we might talk about intercepts and we might say, what are the intercepts on y equals k? All right. So the midline right now is y equals 0 because it's the x axis. But keep in mind, it's really just y equals k. And k is 0 because there is no vertical shift. But if there was a vertical shift of 2, it would be y equals 2. All right. So again, we'll get into that a little bit later. So those are our intercepts. And then we also have our maximum value. So that's a maximum. And this is a minimum. This one I already circled it because it was a starting point, but that's a maximum. This is a maximum and this is a minimum. So each of these graphs will have 5 critical values that we will be identifying as we graph. All right. So some quick practice with amplitude and period. All right, so with amplitude, the amplitude here is not -4, it's the absolute value of -4. So amplitude is +4. It's always positive. All right, the amplitude here is the 1/5. So A is 1/5. It's already positive, so we're good there. We don't have to worry about it. Just be careful because people will just get busy and not think about it. All right, so amplitude, pretty quick and easy. Period, we have to find our B value. So in this one, B is 4. In this one, B is 3. B is a third. B is a half. All right. Now, those are not my period. My period is 2 pi. All right. Period equals 2 pi over the absolute value of B. All right. So that's what we're using to find these. So for this first one, we're going to have 2 pi divided by 4. And then we reduce that to get pi over 2. So that's my period. For example 2, you're going to have 2 pi divided by 1/3. Well, when you divide by a fraction, you multiply by the reciprocal. 2 pi times 3 is 6 pi. For example 3, 2 pi divided by my b, which is 3. Well, nothing happens there, no reducing, nothing like that. So it's just 2 pi over 3. And for my last one, we would have 2 pi divided by a half, which means I have to multiply by the reciprocal. So 2 pi times 2 is 4 pi. All right. Now we've talked a little bit about, period and amplitude, but I want you to kind of see how that impacts a graph. All right. So here's an example of a basic sine curve. All right. If I'm this sine curve, I have a period. Let me do it in pink. All right. So my period is 2 pi. Whoops. And my amplitude is 1. All right. So how could that fluctuate? Well, let's see. All right. So I could have an amplitude of 2. So if I had an amplitude of 2, notice that it goes up 2 and back and down 2. So this one has an amplitude of 2, still a period of 2 pi. Okay. Or I could have an amplitude of 1/3. Well, if I had an amplitude of 1/3, I would only go a third of the way up and a third of the way down. Okay. So it's just a much shorter graph. All right. So that represents, different amplitudes. Now, on the flip side of that, what does it look like for a period? All right. So if I had, this is my standard sine graph, but I could have instead a period. Well, this one has a period of 2 pi, standard period. All right. But I could increase that and say, oh, I need to have a period of 4 pi. Well, if I did, then this would do something like this. I got to try to do it right. Dun, dun, dun. It's weird. Okay. And then like that. Okay. So it's a little bit more stretched out. Whoops. A little bit more stretched out. All right. But I could also have a period of just pi. All right. And if I had a period of just pi, then it would kind of do something like this instead. Okay. And keep in mind, it would just keep what? It would keep repeating. So then it would be like this. Like this. All right. So it would just kind of keep repeating. Okay. Where this graph would keep repeating as well. It's kind of hard to see. It looks like a hot heap of mess, but you can kind of see that, depending on the period, if I have a shorter period, it looks something like this. It looks really tight, right? Okay. It looks really, really tight. Where I could have my standard period and it looks something like this. And then it keeps repeating. Okay. Or I could have a much stretched out period and it looks something like this instead. Okay, so that's just how the period and the amplitude is impacted. Okay, or how it impacts the graph.